All right, today we're going to talk about our exponential word problems. And so these are growth and decay factor word problems. So let's do a quick reminder that your formula for exponential growth and decay is y equals a times b to the x power. Remember that a is your starting amount, that's your y-intercept. And then b is your growth factor, so that's what you're multiplying by. So let's look at this first problem here. It says, suppose there's 5,000 squirrels in a forest and the population doubles every year. Write an equation you can use to find the squirrel population y in x years. And then we want to know how many squirrels will there be in 5 years. So we started with 5,000. So that's your y-intercept. And then since it's doubling, that is your growth factor. And then x is going to be years. So this is the equation. Now it wants to know how many will there be in 5 years. So we just said x equals 5. So we're going to substitute in 5 for x. And then when you go ahead and put that into your calculator, remember it's 5,000 times 2 to the 5th power, and you'll get 160,000 squirrels. That's a lot of squirrels. All right, now here for number 2, it gives you a table. So we have an elk population who's growing exponentially. So that means you're multiplying or dividing by the same amount. So to get the growth factor, you have to take the second term and put it over the first term. So we did 57 over 30. Oops, I'm going to redo that arrow there just because it's showing that you go a different way, and we don't want to go that way. So we're going to do this. There you go. All right, so now let's go ahead. So what I did was 57 over 30, which is 1.9. So that means every time you're multiplying by, 1.9. Multiply by 1.9. Same. All right, so our growth factor is 1.9. Now we have to figure out what's our a value. Our a value is your y-intercept. So your a value is going to be 30. And this is your equation. Now, if the pattern continues, we want to know how many will be in 10 years. Well, x is years. So we're going to have x equals 10. And then now we're going to substitute wherever we see x, we're going to put 10 in instead. And then when you get that, we're going to get this. And then since we're talking about years, we're going to keep it because we haven't started a new year. So this is going to be the answer. 18,393 elk. All right, and then in how many years will the elk population exceed 4,000? Well, you can use Desmos on this, and there's a couple different ways to do it. So what I would do is where'd it go? There it goes. All right, so I'm going to go to here. Is that the right one? Oh, no, that's the trout. Okay, so I'll show you on Desmos in a second with the other one. So we're going to go through on Desmos, and you're going to enter in this equation. And then you'll press enter, and you're going to get a graph. Then you're going to press this you're going to type in y equals 4,000. And what that is doing is it's actually substituting in the 4,000 here. So wherever your two lines intersect, that's going to be your answer. So go ahead and write that down, and then I'll show you on the next example what I was talking about. All right, so now we're starting with 100 trout, and the yearly growth factor for the population is 1.05. And so x is going to be the amount of trout that we're looking for. And we're looking how long will it take for the number of trout to double. So to double, if we started with 100, to double would be 200. So what we're going to do is we're going to first enter in this equation, and then we're going to enter in this equation, and I'll show you my example here. So what I first did is I said y equals 100 times 105 or 1.05 to the power. And then my second equation I entered was this. So when you go on Desmos and you enter in your two equations, it's going to intersect at that point. So when it's 200, this is your answer right here that we're looking for. So you're going to go back 1420. We rounded it. So we're going to say 14.207. Well, since we have, 207, since we haven't gotten to the next year, we're going to keep it at 14 years. All right, so this one is population of roaches, growing exponentially. So it starts with, starts with 2 roaches. Next month, there's 3 roaches. So we're starting with 2, and we know it's going to be growth because your amounts are getting bigger here with 3. All right, so to get the growth factor, you can set up a table if you need to. So we started with 2. Well, next month, we ended up having 3. So your amount's going up, so that's how you know it's growth. So remember, you're going to take this over 2, so 3 over 2. And that's going to give you 1.5. So either would be fine to put into the parentheses. So we're going to take your initial value times your growth factor to the x power. And x is months. So since x equals months, you have to be careful. The next question wants to know how many whole roaches after 2 years. But we said x equals months, so we have to convert this to months. So 2 years is 24 months. So now we're going to go ahead and we're going to plug all of that into your equation, and you're going to get 33,668 roaches. All right, next up, for this one, you have an initial value of 550,000. And then next year, this is your next amount. So if you notice, we're decreasing. So we know it's going to be decay, but we're just going to double check. So we're going to take our second value and we're going to put it over the first value. And we get 0.76, which is in fact decay. So now that we've got decay, or we know that we have decay, we're going to go ahead and start plugging in our information. So our initial goes here. Our growth factor goes here, and we know x is the population of sea turtles decreasing, so per year, so next year, so years are your x's. So it wants to know how many whole turtles after 8 years. So wherever we see x, we're going to substitute in 8 instead, and then this would be your answer. All right, so now if you do a percent for your growth and decay rate problems, so you're going to use this formula if you see a percent sign. So if it tells you a percent, you're going to have to do either add or subtract from 1. So R is your growth rate, and you're going to change it to a decimal before you substitute into the equation. So if it's growth, you're going to use the plus sign. If it's decay, you're going to subtract from 1. All right, so an element with a mass of 800 grams, so that's your starting mass, decays, so we're subtracting from 1, by 21.6% per minute. So we want to convert this to a decimal, so we have to move the decimal twice, so we were here, got to move it here. So we're going to have 0.216, and this is going to simplify to 0.784. So this is actually the growth factor to the x power. All right, now that we got that, it wants to know after 15 minutes how much is left. So we're going to substitute all that in, and to the nearest tenth of a gram rounds to the 10th place. So that's your answer. So really it's just using the information given, plugging it into the formula. It's just got one extra step or 2 extra steps of either adding or subtracting from 1, and then converting your percent to a decimal. So Owen weighs 75, so that's where he starts. His weight is supposed to increase by 3% each year. So remember, your percent you need to convert to a decimal. How much will Owen weigh in 5 years? So we need to find, since it gave us a decimal and its increase, we're going to add 1 to it. So we'll get 1.03 or 1 300ths. And then you're going to multiply by 75. And we know that X is going to be years. So substitute in 5 since that's what we're looking for. And in this case, you could do either of those answers. All right, so I want you to try this one with Wells Fargo, but if it is accruing, that means you're adding or getting that. So it should be, so that's growth. So that means you're going to add to 1. All right, and just remember, move the decimal point twice to get 0.045, and then just go ahead and do 500 is where you begin for 5 years and plug that into your calculator. All right, let's try some of these. I went through that other one pretty quickly because we did the other problem that was very similar. So in 1990, a small town population was 850. The population was increasing at a rate of 1.7% each year. Write a function that represents the population growth since 1990. So in this case, 1990 is actually your 0. So that's your starting point. So be very careful when you're entering in your information. So we started with 850 and it's increasing. So it's going to be growth. And we need to convert the rate as a decimal. So we're going to take this, and we're going to move the decimal twice. And you get 0.017 or 17,000th. Now that we've got this, and it's a growth factor, since we're growing, you're going to go 1 plus that, and you're going to get 1.017. So now put it all together. We need this, and we go 850 times this to the x power. So remember, 1990 is your starting point. So if you're looking for 2018, you have to take 1990 minus, or 2018 minus 1990, which is going to give you 28 years. So be careful with that with your starting point. And now we're just going to plug that in for X. You're going to get 1,362.7. So we're going to round up to the population of the next whole person. And then it says, during what year will the population be 2,000? Nope, did I not do it on Desmos? Okay, I didn't do it on Desmos this time. So you're going to do the same thing we did here, where you're going to write an equation, and then you're going to write the second equation and look for where they intersect. So in this case, you're going to write this equation, then you'll write this equation, and where they intersect is at 50.76. So it's the 50 years. We haven't gotten to the next year yet, so we're going to use 50. So you're going to take your original year of 1990, and you're going to add 50 to it to be 2040. All right. Now go ahead. I want you to try this one. I do have the answers here, but some of the big things is it's decreasing, so it's decaying. So when you're doing this, you're going to go 1 minus your percent. Remember, percent is 1, 2. Oops. And then go ahead, plug it in. And then here, it says since 2010. So 2010 is your 0, that's your starting point. So that's why down here, you're going to take current year minus 2010, which gives you 15. All right. So like I said, go through, finish this out, check your answers here, but these are all how you do exponential word problems. So use the formula, A is your starting amount, B is your growth factor, and if it gives you a percent, you have to add or subtract it from 1 after you've converted it to a decimal.